Okay, today's agenda is to remove C-style casts from the parser and replace them with a new keyword. So what I would like to be able to do is say oh, I can't yet. Anyway, yeah, so I both want to do this U64 like that. I want to be able to do that. And would it be better like that? No, that's fine. I could also do that. Maybe that's what I do. I could have that be the casting syntax. I don't think there would be anything wrong with that. I don't think that conflicts. I think maybe we do that. Well, because the other option is this, and then this would be highlighted like no, I think I like the open close greater than less than. I think I like that. So this would then look like this. Should not have started rubbing my eye. Okay. Let's just start doing that. So for now, let's go back to what we had and have a simpler case first. So go back to that. Wait. Expected semicolon before 10th. What did I do? Oh, because I called it. Okay. Honestly, all this stuff can kind of go. These are the two things I want to have working today. Okay. We want to be able to say this. We want to be able to say this. Right? That's what we want to be able to say. And right now, it's going to fail. Because it doesn't know what that is. So we are going to go to the parser and say we'll just say this. If that are not supported in this language, use here. Short string. This is going to be placement. We'll say DB equivalent is. Let's just say equivalent is this. Let's say result is this. We have a copy. I don't want to skip this now. And we will also so we're going to say the new type, I have it just as a string. So I can just say new type, I think. New type or equivalent. So where is that? That's here. U8 star. Where is this? In platform. Line 89. No. Oh, Linux platform. Right, so this would instead be this. Okay. Right. So, I have that working. So we're now going to say how about we do this? Instead of this, we're going to say this, and we're going to say try parse style cast is going to be try parse style cast, and So that's fine. So we're not skipping tokens. I guess it doesn't matter because we will only, yeah, this doesn't actually do anything if we hit a C style cast. So so we're gonna say try parse. If it is, do that. Okay. And in fact, we can just do this, I think. If result equals that, then error. Otherwise, we can just do this. $13. Did that break? What did I do? No, that's fine. So what did I break though? Expected comma or in it, let's got semicolon on 13. It's in a snippet. Oh, maybe this is happening? No, hold on, hold on. Let's go back to this, let's copy this, and go back to what we had. Back to this. Okay, now we're gonna say, oh, duh. I now need to include that check in here. So that's fine. And here, the first thing we can just say is, if not known type, cast specifier. Turn 0. There we go. Okay. So this again doesn't matter because we're not actually hitting this. Okay. So now let's add a. So first of all, to the lexer, we're gonna say, do we already have? We have less than. So that's fine. We're already grabbing those. So here we will add, not an operator, it's an expression. Yes, it's already white. Yeah, okay. Expression, expression cast. To make this go away. Any unpack, we'll add another one and call it cast. Still good? Still good. Okay. Now, parse expression will be leaf. Where's the leaf? If it's a literal, if it's a keyword, if it's an identifier, otherwise. If it's an open paren, if it's a binary pre, no. So we're gonna add another one of these and say if it is a less than I think I can put this directly in there. Okay, so if it's a less than db style cast. So we skip it, we look at the next token. So skip this whole thing. I want to parse a type here. So just type like thing here. Parse function or variable decal. Parse function or variable decal. Okay, I think I can just do this. Consume properties. It's fundamental type or an identifier. Then well, how about I just grab whatever in there. Okay, this is actually a little bit more involved. So I need to say C style cast, snippet call, any unpack, keyword, C style cast, keyword. Okay. So we're gonna copy this and we're gonna say cast. We have the new type and the new type node. Isn't always set. This isn't always set. Like for types, we don't have the source of. Okay. Sure. Right. So we will say I don't have a parse type like thing here, so how am I doing C style cast? Let's just look what I'm doing there. Create one, get the token text, oh, I guess that doesn't matter. I'm not actually grabbing anything. Okay, this is actually quite simple. So I'm just gonna grab all the words and throw them onto a string. So we're gonna do this, and this is just a cast. This is next line, assert that we have one. Although wait a minute. Create decal ref node, parse function call. Let's not do this here. Let's do results equals parse cast. Parser error context. No. Parser, that's it. Okay, parse function call. So be parse cast. It will take the parser. Assumes cursor is here. You know what? Let's not skip this. Let's just do that. And let's assume the cursor is here. Skip. Closing. Greater than. Okay. So. Next is parser equals peak token parser assert, no, let's say expect token parser next equals peak token parser. We're gonna ask for next. We expect it to be a token less than, and the context is an expression cast. Okay, so we expect a token there. We expect a less than. We can skip it. And next equals peak token parser. So now we can just grab do this. You can just grab everything that's in there. So, expression cast, I forgot to do that. So, expression cast, we can just say the new type is next, while peak token boom. Just grab it. Is that all I was doing? Really? It can't be anything else? Because it could be a keyword. We'll say while peak token parser parser type does not equal. Say while next type does not equal token greater than. We will keep going, and we will say not a greater than, so we get the type. We get the type, and we say we add onto it. I don't think we have to, no, we don't have to do that. So we can say we add onto it and then, okay, we'll say if next type equals token asterisk. We do this. Get token text. It does have it. I don't even have to do that. That's dumb. It's got the text on there. I'll just add all the text. And first equals true. First equals false. If not first, we'll add a space. Okay. And then first equals false. And then we just add the text. And we say advanced. And next equals peak token parser. Okay, I think that might be all I have to do. Return cast node. Parser. Oh, I can close this. I always forget to do that. Parse cast. Okay. And here we say expect token. And advance. That didn't work at all. Expected expression got on 89. Right there. So we got okay, let's just print out the cast node. We didn't even get it. Parse cast. So parse expression. If it's a literal, which it's not. If it's a keyword, it's not. If it's a fundamental type, it's not. Or an identifier. It's not an open paren. It's a less than. Expected expression. In decal variable. Parse variable decal. Expect expression. Oh, because this doesn't. Okay. Starts expression. This could be is a keyword. Is a less than. This could be a less than. Unexpected symbol after got token identifier in map. Oh, because then I have to parse the thing after that as a... Right? Because... Yes, I need this part. Parse cast. So after this, I need to say expect expression I should expect an expression after this. It's a cast. Add a child node to the cast node, which is a cast. And it parses an expression on the parser. Assert node. Okay. Expression cast. Let's handle it in the print AST node. C style cast. Let's just copy this one and put it after here. Okay, so when we print a cast, it will just be the same thing. So we have a new cast expression, cast to a U8 star. And what is it casting? It's casting a function call to mmap. Okay, so we have another one in short string. On line 142. This is now an S64 cast. 166. This is an S64, or this is a new cast. This is a new cast. 194. These are all new casts. Can I just here we'll say instead of boom boom, we'll do boom boom. Instead of boom boom, we'll do boom boom. Okay. And then okay, we're having more of them. 16 of dynamic string. Yep, this is now casting to a char star. 80. Oh boy, all of these. Let's remove this print because it's going to get very unwieldy. Print AST cast node. Okay. C string line 4. Yep. Common 22. Oh boy. All of these we will replace S32 with S32. And here we will replace F64 with F64. And we'll replace U64 with U64. Uh-oh, lines, uh-oh. Is that these? Oh wait, no, it's probably just not, it's probably because we're just not spitting them out now. We might be good. Parsing. Unrecognized symbol. Oh, unrecognized symbol. After identifier. After identifier. So let's see. We are in parse function decal params. Wait. Hold on. Let's remove this first just to make sure we are. Okay, hold on. Yes. Before we move on to this, let's make the codegen spit out the right thing as string. cast. So this will be here. Anytime we have a cast, all we're going to do is create a C-style cast. And this is going to be this. Mm-hmm. Primary chunk. C-style cast. Wait, parsing C-style cast. Why are those still Oh. Hmm. These are CPP files. These are CPP files, which they can't be. All right, well, what happens if I do this? Oh boy. Because it's going to try to parse. So I'm going to loop through all of the DB files, parse them all, and have casts in the syntax tree. Do I have that at least? No, because I'm not getting there. So hold on. So from here, before I do anything, let's print AST parser AST. Just print the AST at this point. And do I have just a cast? I do. I have plenty of them. Okay. And when I see a cast in the tree, I need... Okay, so that's fine. And then I create that, I run the metaprograms. And I don't make it there, I presume. No. Because I run that on the AST, and I output the primary chunk. Although, why am I parsing? Let's do this. Let's go to codegen. Let's go to internal. Let's start here. And then we'll go to the parser and say try parse. We'll go here. Okay. So the cast specifier in this case is an open paren. Binary operator. Oh, I need to know where we are though. I need to know where we are. So let's put that off for now. Okay, where are we? We are in add function. Where were we? We're in a function template. And what is the function template we're generating? Generated function. It is absolute value. Okay, so we add it to the program, create source node from code, we parse the lexer, we're parsing absolute value, so we parse function decal, and we parse it. So we hit the return of absolute value. We're hitting this, and the binary operator is this, right? Parse expression, leaf. The next is parent open. Okay, we're here. Okay. So we're looking at next is a parent open, but it already was a parent open. Oh, let's look at the function text. That's what I should be looking at. Function decal body builder build text. This is what I want. There. Okay, that's why. We are seeing this. So value, that's where we're at. less than 0. So let's just copy this and stick it in here. Okay, here's what we're looking at. We should be right here. At this point. Column 38, I don't think the columns line up at all because that's saying we are here, which we're not. So we've got to be here because we saw parentheses here followed by another parentheses. So we go into here. The cast specifier should be at this point another open parentheses, which it is. Yes. And it's not a known type, so this thing is not a C style cast. Fine. I can remove that, that's fine. Parse expression. Expect expression. That's fine. Next is still the open parentheses. We parse a leaf. It tries this again, and it shouldn't be. So we parse expression. And now we're looking at the value. So we're looking at this. Okay. Yep. Parse the leaf. We should get a decal ref, which is just value. The next should be a less than. It is. It is a binary operator. Okay. Skip it. It's a binary operator. The right is another parse expression. It should just be the 0. Right? Yes, it's a literal integer. 0. Okay. So far, so good. We create a binary operator out of this whole thing, and it becomes our left-hand side, whose children are value and 0, and its type is less than. Great. And now, next will be the closing parentheses. So we just return left, turn the whole thing. Okay. So we peek the next token. It is still a closing parentheses. We skip it. And result should be our entire binary operator. So this parse expression just gave us this whole thing, which is great. So now, that's now our new left-hand side. We peek the next thing, which is a pair and close, which is great. Pair and close, we skip it, boom. So that whole leaf was this whole thing. The next thing should be the question mark, which it is. It's not a binary operator, it's not that, it's a question mark. Okay. Parse expression. Do we still have a breakpoint here? So we can skip over this at this point. Yeah. So we parse the expression. The ternary A should be our binary operator. The ternary B is a prefix, which is this negative value. And the last one should just be an identifier. Turn C should be a decal ref, which should just be value, which it is. Okay, we create the ternary node, so that's fine. That worked just fine. And now our new left-hand side is that whole ternary node. For this expression, this whole thing is our... This whole thing is our expression, our left-hand side. And we should see a... We return the left-hand side. And we're in a return statement, so boom, we add it. The next is a semicolon. We're good, we're good, we're good, we're good. So the next is a curly close. We are done. Return the function decal. Parsed it. Done. Done. We are back in do parse. We add it. Okay. Create source node from code. Our source node is, if we look at scratch parser.ast children 0. It's a source file whose child is a function called absolute value. Good. So, what was the actual error then? It was in... Okay, we're not there yet, I guess. So, yep. Okay. Okay. Okay, hold on. If I just run forward, C-Stock is not supported. So where does this where is this happening? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, hold on. Let's put this back in. From here, we're gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, we parse a lot of these things just fine. So where is the error coming in? Okay, let's do this. Let's make this a little easier on ourselves and say, what was this? Where are we? We are in parser, try parse C style cast. Let's just do static. Okay. Let's just see what X is when we finally hit this. So when we hit this, let's put this up here. Global X. Global X, it's not in there. Static. Global X is 124. Okay, so 124. So let's go in here. When X, or global X is equal to 124. Okay, where did we come from? What are we parsing right now? Struct to string. Okay. And we are in toString, built text. Let's copy this and see what we're looking at. Boom. Oops. That is not the way to do that. I'm gonna go search for that. Boom. Append string. Oh, that's why. Oh god, this is super screwy when you're doing this. What is that? I don't know what that is. That's all garbage. Okay. Here's what we built. This is the problem. Because... oh, duh. Metaprogram U64. This has to be our new syntax. Okay, now we crash, which is, I guess, better than where we were before. Parse literal. Literal string. We're parsing, right, okay, we're parsing that line now. Oh, shit, I left this in here. Can't do that. Okay, we are not crashing. Platform 92. Here in function, expected parentheses before that to match that. You have one though. You most certainly do have that. Oh no, this spat out the code actually. Right, so if I look at the generated code now, both here and the primary chunk, no, it's not in the primary chunk at all, it's here. Allocate virtual memory. $92. So the result is casting to U8, memory let's just see what this looks like, I guess. And if I screwed something up, oh, this function's large, but that's okay. This function is large. Okay. Still not there. Thought that was it. It is not. Okay. Let's take this whole thing and move it out of here to where I can see it. And let's fix it up. That looks weird. Why is there... Oh, that's part of the assert. That's fine. That's allowed to look weird. Getting there. So that's all just the assert. Oh, that's almost it. Okay, great. Oh. Oh, okay, well that's why. Right there. There's an extra semicolon and an extra parentheses. Why? Oh. Needs semicolon. A C style. Wait, what is this? Oh, node depends on. I need that. If the cast there. Needs semicolon. This is also just for a cast. Okay, we compile. We compile. The primary chunks, or the chunks now though, are not CPP files. These are DB files because we have syntax in there that is definitively not C++, correct? So now if I open this, no. Is that true actually? Do we have a toString? No, this is valid C. This has to be valid C because it's generated code. This has to be valid C, right? Right, I got confused. So let's delete those real quick. Actually, let's do that over here. Well, let's just remove the... Let's stop printing this tree. Okay, we're back. Is that it? Am I good? Did I just solve world hunger? Just like that? So this should work. Have a -50. We cast it to a U64 and print it. Okay. What if we cast -50 to a U8 and print it? And it's -50. That would be like 200 and something. 206. That sounds plausible to me. And if I try a C style cast here, it should yell at me. C style casts are not supported. Use U8. Cool. What if I do it in line? S8 of 204. That should be like -80 something. That doesn't work. Oh. No. Why doesn't that work? Because it can't determine the type of that. Because I'm missing one other thing, which is in get param type. Here. If it's a cast, you get the type from its new type. Success, -52. Which if I do 128, or no, 204 minus 128, Wait, negative 52. Did I do that right? If you do negative 128 and no, if I do 55 minus 204 is 51 plus 1. Okay, yeah, nope, we're good. Sweet. Okay, that's awesome. That was not as painful as I thought it was going to be. It looked hairy there for a second, but I think I'm okay. So we have new cast style syntax, or new cast syntax, and we have an error message and pointing you to the new syntax if you use it. So now, if I go back to, let's close these out because I don't need them. Where was this? This was in Memory Arena. Here. So the whole reason I did this was because if I want to use, normally I have pound defines for these push type and push array. I don't want these. I don't want to use macros at all. I want everything to be snippets. So the problem with snippets is because this is evaluated as real code before text substitution of like your parameters, it would see this. And the way I was determining C-style casts is a parentheses followed by a known type. But with a snippet, we don't know what this type is. It's whatever you passed into the snippet. So the heuristic totally fails here. But it sucks because that heuristic's not even a good heuristic anyway. And instead of trying to come up with a heuristic that will correctly identify C-style casts, why don't I just get rid of C-style casts entirely? So I introduced this new syntax for them with the greater than, less than. So in these snippets, I should be able to replace these with this. And now it is totally unambiguous. Okay, well, we're not where we were before, but we're still not working. Dynamic string 31. So I'm calling push array. So this should get replaced with char star, which is right. What did it get replaced with? Let's look. Allocate dynamic string. And which one was this? The U64 version. Allocate dynamic string. This one here. Okay. Oh, because it still says type. That didn't get replaced. Why? That should have got replaced with this. Is that what the error message? Yeah, type was not declared. It didn't get replaced. That's bad. This is in metaprogram. Replace. No, this is in. Oh, duh. Once again, this was a case for C-style casts. I need a case for this specifically to replace the type. Still no. let's look for everything I do with C style cast. Actually, can I just remove those entirely? Let's remove that at this point. We're done with these. C style cast. Let's remove that. Move that. Okay. And then the parser. We'll remove this. This is going to just make this a normal cast node. Grab the stuff. This will be this. This will be this. Okay, C style cast. Okay. This will now fail all over the place where we're using that. Parser.h, did I miss a place? Yes. In the util 189. This is gone. This is gone. 53 is decal with type. This is now a cast and can go at the end. Okay. 89. Get type name from. Yeah, all this has to change. This is where this is failing right now. Oh, this is gonna be awesome. C style cast. We're good there. Codegen 440. You're gone. What is this? Connect types. I'm glad I'm finding these now because these are all places this had to be updated. Okay. 520. This is a much better way to do this than try to like add on wherever I need it. Just removing this entirely means I'm not going to miss a single spot. 1835. Don't need that. 2518. Don't need this. 3010. Don't need this. Okay, we're still not replacing it though. How and why? Replace type. Snippet. Update function call if snippet. Where do I do the snippet like insertion? All of the decal refs. Here we go. Update snippet call nodes. Decal ref, here we go. Snippet param index for string. Wait, all these other places are. This is getting very cold in here. I'm confused. That should be working identically. There's not a chance it's because of this, is it? That can't be, because we're on the token level here. No. What about this? No, it's just straight up not replacing it. Why? Let's just go to update snippet call nodes and see what it's doing. So here, I need to look for dynamic string, line 31. Call source, line number 31. Okay, call source is a snippet call to there should be a call to push something something. Push array. Yes, we're right here. Okay. So we are going to look at what is the snippet copy node though? Oh, that's the snippet that we're replacing this with, which has 3 parameters and a body, which it does. Yeah, it's push array. Okay, we're good. We're good. So for each child node and snippet copy node, if it's a decal ref, so in this case, type here is a decal ref, so we should see that. Let's go here. Okay, this child is a decal ref, and it is push size. We didn't even see type. We did not even see type. Why? Okay, different approach. Let's say if call source line number is 31, print ast snippet copy node. Let's just print out the snippet when we hit it. I'm printing something else out that I need to stop printing. Okay. That's a lot of things. Push array, push array, push array, push array. Arena type num elements, arena type num elements, arena type num elements. Arena. Let's do this. Let's print out the call source also. You know what, let's print out all 3. Because I don't really know what I'm looking at any given time. Print all 3, and then a new line. Okay. Snippet call, arena char size. Arena char size. So this is it, I think. This should be it. So I want to replace this cast expression Oh, that's why. It's a string. It is a string. Cast expressions are just strings. There's not a node that I'm looking at there. Okay. Ooh, this is... What do I do there? Okay, well, let's see what we can do. There's a couple ways I can go about this. So, for this very reason, no, man, okay. This is a little gross, but if the child type in this snippet is a expression cast, what just happened? We are going to, for now, just say print node nicely. No, we're gonna print AST snippet node. What is it? Snippet copy node. And then we're gonna assert message false. Yo. Okay. So that's where we're asserting, because we're hitting it right there. So I should also be able to just say, actually let's do this. Let's assert and say child info expr cast new type. Let's just print out the new type. Oh, because this has to be a... I forgot. This has to be a... God damn it. Type C. C string from this type C. Okay. Yes, so, and this will instead, we'll do this, and this. Okay, so here's the type that caused the assert just now. So we don't know what that is. We need to learn how to handle this. So to do that, I think we just need to do a textual replacement of, I need to search for the snippet parameter text. So in this case, I'm searching for this text. In this case, it's type, and the trimmed version of it, so no spaces, and only with alphanumerics on either side is when I know to stop. So if this was like, if there was no space here, it wouldn't grab this, it would stop at type. And I think that covers my bases for what you can have in there. So let's say new type is what is the new type? The new type is Snippet param for... How do I get the matching param? Snippet param for variable, snippet param for string. All right, hold on. Let's print the snippet. What are these things? Okay, the source is I'm passing a source and a copy of the source at the same time. Why? Because that's what I'm referencing to get. Okay, so it's the call source. It is the, let's do this. Snippet param from call source param from snippet param. And we're going to pass the call source, and we're going to pass the snippet. You know what? Let's not even make a function for this, because I'm just doing this right here. I think all I have to do is say the snippet param ID is child index, right? Wait, oh man, I'm getting confused here. There's a lot going on here. Let's look at this again, actually. Hold on. Let's go back and print these things out again. Where did I do that? Nope. Okay, well, let's do this. Assert false, and we will print snippet source, call source, snippet copy node. Okay, so we want to replace this here, which is child, yes. So we want to replace child's inside the string of child. We just need to find the corresponding call source parameter that matches this child, right? But doing that is, I need to match in this string any of these parameters. Okay, yeah, we do want to isolate this. So let's say try replace cast in snippet. And it's going to be the snippet copy node, because that's what we're replacing it in. And This is the cast we're replacing. And, well, I guess I don't need this if I have the child. So that's the cast we're replacing. And we need the call source, right? Because I want to replace this with this. Right, this is push type. Hold on, I'm not even looking at the right thing anymore. If call source children 0 okay, let's do that. Print AST call source. Uh-oh, that didn't do it all. Oh, not push size, push array. Okay, we're back. So here's what I need. I need to replace in this child. I just need to replace this cast. So in child, I need to replace with if any of okay, this is actually, I can make this a little easier. So if I also print out the snippet copy node, stop. First thing I can do is figure out, is this one of my snippet parameters? Yes or no? And I can do that because the, not this, I need the snippet source. So I can say, okay, I need to replace this with, I need to first of all know, does this cast have any of my parameters in it? My parameters are all right here. Easy. So this thing needs the snippet source and the child. So first thing, do I find this, or this in this string anywhere? If I do, they gotta be replaced. That's step one. So if they do, what do they be replaced with? Say I find this one, which is the second parameter. I then go to the call source down here and grab the second parameter and stick that in there. Got it? Got it. So we're gonna say try replace. It's gonna take snippet source, it's gonna take cast, and it's gonna take call source. Okay, first thing, determine if there is anything to replace. So let's first get cast string is cast info expr cast dot new type, and let's just take this one step at a time because it's confusing me. cast info. Oh, okay, there they are. So, okay, so first things first. For each node of type in tree, so in the snippet source, look for all the parameters, which is, what were they? I think they're pre-proc params, yes. So I will look for all the parameters, print node nicely. Let's just do this real quick. No, I know I'll find them. So if string contains exact, we'll take a short dynamic string, dynamic string, query. Return false. Okay, best way to do this is so I'm going to be checking for okay, that's probably the best way to do this. If I go, let's do it like this. End index equals query length. If end index is less than, if it's greater than query length, we're going to say I basically want, so if we're looking for this inside of this, this is 4 characters long, so we will look at, so it was like this, right? We will look at 1, 2, 3, 4. Okay. That doesn't match. So we'll do that. That doesn't match. So we'll do that. That does match. And then we'll look at this and this and make sure that neither of them are alphanumeric characters. So what I want here is, is my substring protected? It's protected with an assert. That's not great. What about with length? Do I have a length? I don't have a substring that gives a length parameter. Okay, that's fine. Here's what we'll do. We'll say for query index less than string length. So we can only go as far into the string as we still have room. So this the length minus the query length is as far as we can go. So as long as the index that we're starting at is less than the end of our string minus our query length. So as long as that's true, let's get a substring. Chunk, we'll call it, from the string query index plus query length. There's probably a +1 that needs to be in there somewhere, but I don't really feel like thinking about it right now, so I will do it the brute force way. So this should show us, oops, stepping through query length. Would help to call it. Always helps to call it. We're looking for, in cast string, we're looking for this node's, what is a preproc parameters? Data look like? Great, just the name. Proc param name. Cannot convert to dynamic string. This is not changing. I'll just make it a short string pointer. Who cares? Okay, so we start at type. So this looks right. I don't know. Am I still printing something out here I shouldn't be? If I don't do this, no, okay, something is not. Query index is 0 to is less than that. This should be a -1, I think. Don't quote me. Oh, there's a space in there too. Let's trim this. For every chunk, we will trim it. Do I have a trim for dynamic string? Trim cursor, trim. Trim, are these, this is a cursor, so trim cursor, chunk. Okay, so that's still confusing me because I feel like this should be what we should be seeing is type and then I should less than this isn't a -1 too, is it? No. So we're seeing from 0 to 4, but then we should be seeing, I don't know why we're seeing 2 of these. That's my confusion right now. You know what? Let's just go into it. Why keep guessing? Here we go. So query index is 0. The query itself is arena. Oh, that's why. Duh. Because we're looking at arena first. That's not... We're looking for query string. Duh. Okay. Here we go. Okay. Here we're looking for arena. So we're looking at type, space, so that's the whole string, arena. And if we go one more, okay, there should not be a -1 there. I don't think, because now we're missing ARENA. There should be a -1 there, but is that a +1? Yes, that's what I was expecting. Okay. Type, we're looking for arena. We're looking at that, so we're looking at this first, and then this. That, and then that. Here we should be looking at 4, 4, 4, and then we're out of room. This is working. So, so that's great, but now we need to handle the case where if this was called like my type, now wait. Oh, we hit an assert. What happened? Although, wait, that still should not have... Oh, wait, no, that can't happen. Never mind. It would have to be... Oops. There would have to be, if this was called my type. I got confused. Okay. Other way around. If this was called... no. If this was called like my arena, for example. Oh god, I'm getting so confused. No. I need an example of this so I know what it is, what a pitfall might be. So this was type, and this was my type. Sorry. If this was my type, yes, if this was my type, this was type, and each of these were my type. Jesus. Brain is hard today. Here, this is the case I wanted. So, if we're looking for type in my type, that's not it, obviously, that's not it. This suddenly is. This will say, hey, these are the same, we found it. In which case, I need to first say, we can stop writing these out now. We can say, if chunk is query, assert, yo, we found it. And actually, let's, I don't need a new line there. Let's keep these prints in so we know where we found it. I'm the master of removing prints and then realizing I actually want them there. Did I need that +1? I don't know. No, because I think that's why we're failing here, huh? Although that should have stopped. We write the chunk and the query. Oh. I'm not paying attention. Assert false there. Okay, yo, we found it. So, yes, in this case... God damn it, it's because we're doing it earlier. Get rid of you. My type, my type. If chunk equals query and chunk dot length does not equal query length. No, it does equal query length. So that's when they match exactly. This should match here. That's 4. This is clearly not 4. And here they match. So why is it not asserting there? Let's do this. Chunk equals chunk equals query here we go. So add one more thing here. All right. Type equals arena. No. That equals arena. No. Type equals type. That should stop. Let's do this. Chunk equals query. Break out of the loop. And separately, if this, we will assert. Okay. No, no. So this did, so it stopped immediately. Nope, nope. That stopped immediately. Nope. This stopped immediately. This broke out of the loop. So this stopped here. And it shouldn't. Okay, this is not the exact way I wanted this example to go. So why didn't this work? The chunk length and the oh. No. Oh, the chunk length will equal the query length. It has to. Right. That's a dumb assertion. So if the chunk equals the query, I think all we have to do is say if query index, and so if we are not, if we have a character to the left of us, then chunk data do we want to trim it? I don't think we want to trim it actually. I don't think we want to trim it. Let's not trim it. So if the chunk equals the query, then if we're not at the beginning and chunk data query index -1. So if this is, if not is alpha. So if we're not at the beginning and the thing behind us is not an alpha character. And also, query index is less than string chunk. No. String length -1. So if we're not at the beginning and if we're not the first character and there's not an alpha character behind us, right, I'm checking to see if we matched exactly that. I'm just double checking that if on either side of us here, we're gonna do something, otherwise we can break. Otherwise we know we're good. No, we can just return true. I guess here we just continue. So if our first character to the left of us is not an alpha character, and the character to the right of us not is alphanumeric, I can actually use the chunk data here because it is just a substring of the okay. Okay. Arena, so that's false, type true. Arena, that's false, type true. Arena, false. My type true. My type and type is true, so that didn't quite work. Oh, because there's another case here, is if and is, or we're the last one and this is, then we continue. False, true, false, true, false, true, false. I think we're good there. But we do break here. When I take this, it's because that's going one too far. But it has to go one. It has to, does it not? So substring dd. Is this what's failing? Yes, this is what's failing. Assert that end index is less than the source length. So in this case, string. So the end index is greater than our length at one point. So so if we're going from 0 to Well, where are we actually breaking? We're getting through all these. This one's failing. U64 to bytes. So if string equals U64, U64 to bytes. So string length is 3, query length is 5. True. We break immediately on that one, so that's not great. So query index is 0. Query index plus the query length. Duh. If our query is greater than or if our query length is greater than the string at all entirely, it can't match. It can't be in there at all. So if query length is greater than string length, turn false. Okay. Man, you can tell I'm tired or something. Something's going on because this was not that hard of a thing to get through, and it took me a lot of brain power. So if the string contains exactly, if the cast string exactly contains the parameter name, let's have this just do the thing. Replace string exactly. And you know what? We don't even care if we don't do anything. We just don't do anything. How about that? Replace string exactly. So in this case, do I have like a replace or something easy? It doesn't matter, but oh, this would be in short string. Replace all instances of character. Okay, doesn't matter. So for replace index, place index is less than chunk length plus replace index. We'll say string. This is no longer the case here. This has to be directly the string that we're replacing in. So cast info expr cast new type. So this is going to be the exact string that we're replacing it in. Replace in string exactly. Okay, so this can be that. We'll say string dot string arrow. This is now just a void. This is no longer a pointer because it's already a pointer. Now we're going to say string data. Query index plus replace index equals chunk data replace index. oh, this is no longer a dynamic from a dynamic, it's a dynamic from a short string. Let's put these back. Although that error message does not fill me with hope. Type was still not declared. And we will return in this case. Did we ever do this? We did. So we'll say print node nicely. Or no, we'll say write. Well, yeah, we'll do this. We'll say print node nicely cast. This doesn't print it very nicely if it's not putting a new line, but whatever. And we'll do it after as well. And sure. Hey, I'm doing okay. How are you doing? Solving problems that are it's making my brain hurt, but okay, so that's not replacing anything. Let's add a new line here though, just to better see. So we're not actually replacing anything, but we are finding oh, this is not the chunk that we're replacing it with. We're replacing it with the query. I actually think I'm about to solve this problem, so go ahead and throw your question in the chat though. I will definitely get to it. Let's type. Okay, I'm missing something there, but yeah, these are not Vim key bindings. These are so Emacs has its own weird key bindings that I also never used. So I wish there's an easy way for me to show you my keyboard, I guess, but the moving the cursor around is all arrow keys. It's up, down, left, right, and Emacs and 4Coder both have a jump to next white space. So if I hit up and down, I go by line. If I hold control and hit up and down, it jumps to the next new line, which is why you'll see a lot of times in my code, it's informed how I format my code. So I always put like a new line before the return statement, for example. And for more complicated if-elses, I put them because it allows me to jump through stuff very quickly. And that's like a background process in my brain. I'm like not even thinking about it. That's just how I have trained myself to do it. So that's 90% of what you're seeing is control arrow keys, because it also works left and right. I can jump to next white space left and right as well. That's the primary thing. And then page up and page down to do what you expect. And I do control F a lot to just find. So like if I want to go like to another function like that update snippets, I'll just F update and then I'll just go to it. Yeah, because Emacs I know has its own like don't leave the home row keybinds as well that I just never got used to using those. So and then the other thing you're seeing that I also got from Emacs, Control E. So if I'm going up and down, if I hit Control E, it just centers the view on wherever my cursor is. So that's how a lot of times I scroll through my file, is I Control up a couple times, hit E, And that's how I'll typically navigate the file if I'm going, if I'm just trying to like scroll through my file, I'll do that. So the query, oh right, I'm not replacing it with the preproc name, I'm replacing it with the corresponding call source param. Okay, that's what I was missing. Duh. That one I need to replace with call source, and we'll pass the pointer to it because why not? Call source info, no, children. The first one is the function call, so it's the child index plus 1. So this is going to be info, decal variable name. What do you call the thing that is replacing something? I'll just say to replace with. So this should be replaced with. Yes. Oh, but the replace with might not be the same length. I can't just do that. Okay. Right. Okay, let's not do that yet, but let's at least make sure this worked. Child index. Oh, it's not child index. It's oh. This. Let's replace this for each child node in that. If child type is not a preproc param, then just continue. Then that should work. Which means this is no longer node, this is child. Okay, so in this case, we're replacing type with string builder node. Or we're replacing, not string, we're replacing chunk. So in this case, in type star, we're replacing type with string builder node. In type star, type with string builder node. In type star, we're replacing type with character. That looks right to me. Now I just have to do that. So, do I have an just like insert character? Append character to start. But it can't, it's not necessarily at the start. Okay. This is a little gross, so in the string, let's do this. Query. So we looked for type. No, hold on, this should be string chunk. So in type, what is this last thing I'm printing? Okay. In type star, we were past type star, we have to replace type with this. So in this case, Okay, so I need to do something that is gonna stress this. So instead of replacing type with string builder node, let's replace I need to replace okay. So the first part, I can say first part is final string will comprise A plus B plus C, where A equals part of original string left of the chunk found. B equals replace with. C equals part of original string right of the chunk found. So short string A final A will be substring SS. It will be string 0 query index. So from the beginning of the string to however far we got. And then the middle part will just be replace with, that's fine. Final C is gonna be in string, it's query index plus query length minus 1 to the end of the string. Which this can really actually just be a head and a tail. Right? No, this would have to be query length minus that. I think I don't know. Let's write output final A plus replace with plus final C. I don't know, man. Doing some wacky stuff here. So type. Okay, that's shockingly close. Query index minus 1. Although wait, that can't. No, hold on. Oh, that's an index. This should be in. This is a length. Query and yes, those are that's head in of string query index. So in this case, query index is what? In this case, query index should have been 0. We should be right at the start. So head in should be 0. Head in. Oh. Oh, I don't have a head in for short strings. Ah, why is my eye itching? Let's grab all these and create them for well, I guess these can be dynamic strings then. Sure, why not? Who cares? Okay, goddamn, my eyeball. I saw a bunch of animals today with family and did not properly prepare my allergy medicine. Okay. Let's just do this. Let's just print each one out. We'll print out final A. We'll print out replace with, and we'll print out final C, and then the whole thing. So that's not right, because query index in this case should be 0. It should be 0. It is 0. Wait. Head in. You... How did I manage that? Bro, come on. Give me a break. String builder, awesome. There's just one extra thing there, which means this -1 should not be there. Or -2? Why would that be -2? Why is that -2? Because it's the tail end of the string whose length is equal to, oh, this should be how much is left in the string, which is the string length minus that. Yes, it's the string length minus how far we got into it. Okay, I like that. So that means we can say string equals that. Yeah? We compiled, ladies and gentlemen. We frickin' compiled. Okay, where did that leave us? This worked. With this being snippet calls. With our new casting syntax. This just took all night to do. But it is working. We are there. Success. I now have new type casting syntax that is totally unambiguous. And if you try to cast using the old C-style casting, you get a failure in parsing that says, hey, C-style casts are not supported, and it shows you what it should be for the cast you just tried to do. You should use that here instead. And it works inside of snippets. If you use type here, it will work. Awesome. So that was initially, God, what was my, that was a sidetrack of a sidetrack, so, but that means this is done, right? That is done. Get rid of all this stuff. This is what the other thing I wanted to do, and it's late, but holy crap, this took so much longer than I thought it would. This I don't think will take very long at all, so I do want to do that. And what that entails is this case. So we have this function called absolute value. It takes an any parameter. If the parameter is less than 0, it's negative that. Otherwise, it's, you know, just your absolute value function. I want to be able to print out the absolute value of a number you pass in. Let's comment this one out to start. So if I go like AV, U64 AV, actually we'll say S64 just so we know it's not doing any shenanigans. So if I say S64 of that, we should get, and we'll say this, we'll say value equals -2514, value, and AV. So we should see 2514, negative and positive. There we go. -2514 equals absolute value 2514. That's actually not what it should be. Should be this. The absolute value of -2514 should be 2514. But if I do the exact same thing and I put this directly in here, we still work great. But if I take this whole function call and put it in here, we fail to parse. Unrecognized symbol. So the problem here is, the way the metaprogram works is it sees this function call to print. And it's like, do I know what print is? Let's go look. I don't know what print is. But you have a function template, and a function template is just anything that has an any parameter. Any function that has an any type in the parameter. It says, do you have a function template that matches this? Well, this one takes a short string, a integer, and a, oh, I don't know what this is. Let's go look up what this is. Oh, there's no function for that because this is also a function that gets generated. So this fails entirely. It doesn't know what print it should go generate because it doesn't know what this is. Because this is also a function it has to generate. And right now, those are happening in chunks, I call them. There's your main metaprogram, which outputs the first chunk of generated code. The metaprogram runs on that, which generates the next chunk of primary code, runs on that, and it goes until it's 0. This should not be part of that secondary chunk. This is a citizen of the primary chunk, because these are both seen on the first pass of the program, which means when I see a function call, before I go to resolve it, I need to make sure that I resolve all of its parameters first. So in here, generate function templates, I'm saying for each node of type, for every function call in, and let's just be explicit, that was from older code, for every type in the AST that is a function call, I can look up any meta function templates that match it. But in order to do that, I have to check the parameters, right? And before I do that, I need to resolve what those parameters are. So, did I just put that in there? Why is there a slash in there? Hello? Whatever. So, to do that, if when I see this function call, I loop over the parameters. For the required parameters first, let's make a function called resolve param if function call. And this is going to take the AST and it's going to take the param. So call argument. Right, before we call get param type, we say resolve param if function call arg. Pass the AST. And we do that same thing down here for our template param. Okay. And what that will do well, it should really just do the same thing, honestly. Can I just do that? Is this all I have to do? It can't be this simple. Instead of this, can I just generate function templates on... No, not even this. Before we do this parameter stuff, can I just do this? Can I just generate function templates on the function call? First time? There's no way that's gonna just work. This is gonna explode. Okay, it didn't explode, but it didn't do anything. This also doesn't need a first time. Okay, let's see what this shows up as, though. Let's just see what happens. So, where are we? Oh, God. Here. Let's say if declref info export declref dot decl name equals print. Let's just do it for print. How about that? So I can break here. Nope. 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 Okay. Print. We go into here. So the AST should be our function call. Its children are a declref, a string, a unary pre, and a function call. So we should find it. Node is the function call to absolute value? Yes, we're here. We found it. We're not inside a function template. We're not part of a snippet. Our children 0. Is a decal ref. Okay. For function. Okay, did we find a match though? Is the question. Let's see if we find a match. Are we still in? We're still here. So we did find a match for absolute value. We found it. Yeah, we did find it. Okay, hold on. Hold on. Let's get down to here. Our generated function. What did we get? That looks good to me. We got the right function generated, so it did generate it. It absolutely generated it. Great. Awesome. Okay, we're back at print, I think. Decal ref. Okay, we're back at print. It generated a function call. Generate function templates for that. Oh, but did we actually connect it up? Function call, children, decal ref, info, decal ref. We didn't actually connect it. Right. When we generate it, add function decal to program. Connect function calls to generate a decal. Okay, hold on. So we're not quite done yet. Let's step through that again and figure out what happened. Okay. So we should have generated it after we did that. I need to see what we did. So, boom. Okay, we generated it. So, when we go, oops, again, let's go back in here. And now I want to hit this in here, add function decal. It exists. Why does it exist? Oh, no, that's fine if it exists. Oh, okay. If the function already exists, we still want to connect it. We still want to connect it up if it already exists. This needs to still happen no matter what we do. So we're gonna say result equals 0. A function node results function node, else hold on. What's the best way to do this? So if function node, then we return that. Otherwise, so we always want to do this at the end, no matter what. And this will be result, and this will be result, and this will be result. So, in this case, result equals function node. Else, if not global, then do that. Result equals function node. Man, this is actually kind of gross. I'm gonna do it this way. Result if not result and not global. This is a horrible way to do this, but I kind of don't care. Skipping with no body, that's fine. Result equals new node. Okay. Okay. Results. I don't have result. Still didn't work. That should run first, though. I think we are getting there, but so is this absolute value? Okay. We have function node. Oh. God, this is gross, but whatever. Okay. Let's do this and do this. Okay. Okay. Connect function calls to generate a decal, and the output AST is the primary chunk, which is fine. We'll go in here. Function call. If function call matches decal. So the node that just matched is absolute value. It did find it. And your parent is, wait, signless part. Oh, I'm not even in the right place right now. What is happening? I dare say, what is happening? go here. It generates the absolute value function. And the current global AST is primary chunk. So this is going to generate after this. All it has right now is absolute. It already has absolute value. So it should have connected it. It should have connected it in the first step. No, the function didn't exist yet. Hold on. Connect. I'm breaking out of it. Why am I breaking out of it? There's other ones that need it. Oh my god. I am truly... I already had this working, I just had a break in there. Oh my god. Okay. This works. This works. I still need the part I did though, right? It was just this one call that I all had to make, that was it. That still works. Why does that still work? Because... Why does that still work? I feel like I need that in there, but that's what my gut's telling me. I need that in there. But hey, whatever, this works. What if it's a function call inside of a function call? So what if this is like, give me a negative. And this is give me a negative. And give me a negative looks like return negative 404. All right. Well, that's fantastic. That is the whole thing right there. Really? That took 2 seconds where the first thing took all night. That's done as well, I think. There are no more defines in there, are there? Define in... No, there is not. Bro. That just works. Wow. Okay. Let's finalize this into its own first-class citizen. Tasks, I guess. Stream agenda. That I still want to do. That I still want to do. Okay. Well, that's awesome. Function templates just got a whole lot better. Now properly function calls to function template. Calls that generate functions from templates now properly resolve their arguments first. And also, I should say, no more C style casts, new syntax for casting, calls do. Okay. Man, that's awesome. Okay, I did want to say the other thing I want to do is shit, I just had it. What is it called? I have it in here. Generate these with any can I make how about a specific any syntax? Which will be like inline u64 absolute value. Okay, let's just copy this. How about that? This will say I want it to be S8, S16, S64, or S32, S64. So the next step I want to do in all of this is I want to be able to support, instead of just any, you should be able to say this exact thing here. So it'll still generate functions, but it will be type checked to know. You can specify a list of types specifically that, so it's technically an any, but it's restrictive to just those types. So it's like, I don't know what you would call that, but you're basically restricting. It'll still generate functions for you, but only for those specific types. Anything else will be an error during parsing. So yeah, I'm excited about that. That will be, I think, pretty easy and very cool. So yeah, I guess I'll just call that specific any. I don't know if there's a better word for that, but and let's reorder these because I kind of want to do that pretty soon. And this can also come out. That's what I want to do first, actually. That's going to be fun, and it's going to be a freaking cool new feature. And yeah, okay. Man, that's awesome. Okay. I didn't actually save that, so all right, great, cool. Well, thanks for watching, everybody. That was a very productive night. That first problem took forever, but got there. No harm, no foul. This is really shaping up to be kind of bigger and better than I ever could have hoped for, and it's going very well, so I'm excited. Next time will also, probably tomorrow, will be another really awesome feature. Having this is gonna be, it's gonna be sick. So thanks for watching. I will see you tomorrow if you hang out.